Jai Shri Gurudev. Good morning to everyone students. Welcome to chemistry class. In this session, we are going to learn the relation between the nearest neighbor distance, that is represented as d, small d, and radius r, that you know, and edge length a. Here we are going to the relation between nearest neighbor distance d and radius r and edge length a. Now observe the definition of nearest neighbor distance is defined as the distance between the center of any two adjacent atoms is called nearest neighbor distance. You know, in solid state, any crystal or in solid crystal, the atoms are in spherical in shape and these are adjacent to one another, or these are interconnected with less space, or these are closely interconnected in the manner like that, or in the row manner. Now observe here, the nearest neighbor distance is the distance between the center of two adjacent atoms is called nearest neighbor distance d. This distance we call d. So already in cubic crystal lattice or in the simple cubic lattice, the nearest neighbor distance d is nothing but edge length a. So in simple cubic crystal or primitive cubic crystal, the nearest distance is nothing but a. This is called nearest neighbor distance. Remember, nearest neighbor distance is the distance between center of the spheres of any two adjacent spheres is called nearest neighbor distance. Now here we are going to define the relation between nearest neighbor distance d and radius r and edge length a. In simple cubic crystal lattice or in simple cubic crystal unit or primitive cubic crystal unit, the distance, the edge length a is equal to 2r, that you know, because observe, in simple cubic crystal we are writing like that. This is the simple cubic crystal, and each corner there is a atoms like that. In each corner there is a atoms. These all touches to one another. They are not written the touching of these spheres, but actually these two are touches to each other. This can be represented in simple way. Here there is in every corner atoms. In each corner there is a one atom. Those are interconnected to one another. Now observe, in this sphere I am taking these two, or take any two of this cube. Let's take this length AB. At A there is a one point, and at B also there is a point. Now observe, one sphere is particle A is like that, and the particle B is this one. These two are touches to each other, but they are not touching and not written like that. It is difficult to write in three dimensional on board. So let us assume this is the particle A and B. Those two are connected to the distance this one. This is called nearest neighbor distance, that we are represented d. And to find fraction efficiency, we are assuming the edge length is a. So this is the edge length. Hence, in simple cubic crystal or primitive cubic crystal, the edge length a is equal to distance, that is nearest neighbor distance. And we are saying that the radius of each sphere is r. The radius of each sphere is r. Therefore, by this assumption, we should say that a is equal to what? 2r. A is equal to 2r. That is only I have written there. That is a is equal to 2r, and that a is nothing but what? D. Hence, that is equal to d. Therefore, the nearest distance d is equal to a in simple cubic crystal unit. In this case, d is equal to a. That is edge length edge length is equal to nearest neighbor distance in case 1, that is simple cubic lattice. Then in case 2, in face center cubic crystal, in face center cubic crystal, that is in FCC. In FCC, there also we are saying that nearest distance D is equal to 2r. D is equal to 2r. But observe in face center cubic crystal, at each face there is a one more particle or atom. So each phase having a one more particle ಅಂದ್ರೆ ಪ್ರತಿಯೊಂದು ಫೇಸ್ ಅಲ್ಲಿ ಒಂದೊಂದು ಪಾರ್ಟಿಕಲ್ ಇರುತ್ತೆ ಫೇಸ್ ಸೆಂಟರ್ ಕ್ಯೂಬಿಕ್ ಕ್ರಿಸ್ಟಲ್ ಅಲ್ಲಿ. ಅದಕ್ಕೆ ಇಲ್ಲೊಂದು ನಾವು ಕ್ರಿಸ್ಟಲ್ ಬರೀ ಸಿಮಿಲರ್ಲಿ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಫೇಸ್ ಕಂಟೈನಿಂಗ್ one crystal and here also one crystal means in each phase there is a one crystal unit that can be written simply like that. Observe, that can be written simply like that. Observe, let's take one phase in one phase draw an angle, straight line, right? Here one line that is connected to the opposite corners of the cube. Now you get a triangle. Now draw the triangle. So observe, this is the triangle and let us assume this is A and this is C. Already we are denoting B as C and this is D. That is A, C, D. This is the triangle and at D there is a one particle and at A is also there is a one particle and at C also there is one particle and between there is a phase, that phase also having one particle and we know the distance of radius of the each particle is assuming r, hence there is 4r. Let's assume this is edge A and this is edge length A. Now find the distance of the CD line or length of the CD. Find the distance or length of the DC or CD by applying Pythagoras theorem. Already we did to derive vacuum efficiency in FCC. There you get, let assume this is the edge, this is the line. Let assume its length is x. Now x is equal to how much? X is equal to 4r because there is 4 radius. X is equal to 4r and by applying Pythagoras theorem you get x is equal to a into a, that is a square, that is x square is equal to a square. By applying Pythagoras theorem you get x square is equal to 2a square, that is dc square plus dc square is equal to sum of ad square and ac square. dc square is nothing but x square plus sum of this ad square and ac square, that is ad square is nothing but a square and ac square is equal to a square, that is equal to get 2a square. Now compare these two and find the value of r and substitute here. Compare these two. X square is equal to 2a square, therefore x is equal to how much? Root 2 into a. Root 2 into a. So what you get by this triangle? You get x is equal to 4r and x is equal to root 2 into a. Root 2 into a. Now find the value of r. Compare these two. 4r is equal to root 2 into a. Now find the value of r. R is equal to root 2 into a divided by 4. Divided by 4. Now substitute here in place of r. T is equal to 2 into root 2 into a divided by 4. 2 ones are 2 twos are. And you know 1 2 containing 2 roots. Each 2 means 1 2 containing 2 root 2's. 2 root 2's. 1 root 2 1 root 2 get cancelled. Finally you get a by root 2. Therefore, after simplifying this whole thing that is equal to 2 into root 2a divided by 4, that is equal to, you get d is equal to a divided by root 2, that is 1 by root 2 into a, that is equal to, that can be written as 1 by root 2 into a. So remember, this is the edge length, nearest neighbor distance in FCC, that is face center cubic crystal. Similarly, the third case in body center cubic crystal in BCC. Body centered cubic crystal. In body centered cubic crystal, you know D is equal to 2R. There, to find the value of R, we get Y is equal to 4R. In this case, we get Y is equal to 4R. In this case, you get Y is equal to 4R, and find the value of X. You get 2x square is equal to 2a square and y square is equal to 3a square. To get values of x and y, you already know how to get these values by solving to find the factoring efficiency of BCC. You get those values, and there by comparing this 3a square and value of r, after finding the value of r and substituting, you get D is equal to root 3 by 2a. Get the value of D is nothing but root 3 divided by 2 into a. This is the nearest neighbor distance in BCC. So you should remember to solve problems in simple cubic crystal, the nearest neighbor distance D is equal to a, and in face centered cubic crystal FCC, the nearest distance D is equal to 1 by root 2 into a, and in BCC, the nearest neighbor distance D is equal to root 3 by 2 into a. You should remember these three values, that is nearest neighbor distance in different three types of crystal lattice, crystal units to solve problems.